Go. Hello, Mr. Ryan, how are you say? We have talked about LIS, longest increasing subsequence. Longest increasing. What's subsequent? Yeah? Subsequence. What's the difference between subsequence and subarray or sublist? Which one is continue? Okay, so look.
That one.
3, 2, 4, 1, 7, 8, okay, 10. Sublist continues, so it has to continue.
That
Yeah?
one.
Yeah? And usually with the sublist problem, we can brute force in ON square term, right? Because we can try every possibility of sublist by determine the left point and then brute forcing the right point. That's ON square. But for subsequence, what's a subsequence? Subsequence is you take arbitrary number of elements from the original array, you delete it, yeah, and then the remaining is a subsequence. For example, it does not have to be continued like 3, 4, 7 or 3, 2, 4, yeah, 2, 7, 6. Okay, 2, 7, 6. Is this a subsequence or sublist?
Sublist. With subsequence.
And you?
Subsequence.
Yeah. Okay, you're listening. Okay. Okay. So longest. What's the longest subsequence in this case? What's the longest subsequence? What's the longest subsequence? Everybody, what's the longest subsequence?
3, 2, 4, 1, 7, 6, 10.
Longest increasing subsequence. Okay, increasing subsequence. But you're right about the longest subsequence. I didn't say increasing. Yeah, it's the whole thing. Yeah, great job. And increasing. How about sorry, increasing one.
All I can find is pairs. These two.
Can you 2, 4 increasing subsequence? You know, it does not have to continue. The longest,
I
like
get it.
the longest subsequence. Which one you don't get it?
Long as increasing sub.
Longest increasing, like 2, 4, 7. This is increasing. Always increasing subsequence.
1, 2, 3, 4.
What? No. It has. Wow.
Hey, you said 2, 4, 7.
Yeah, 2, 4. I
Yeah,
know.
but then why? How come you can't do 1, 2?
No, just
4.
Just this way. Just this way. You pick it. Longest increase. Subsequent. Remember, we talk about subsequence.
Yeah. 2, 4, 2, 2, 10. 2, 4, 6, 10. 2, 4, 7,
Okay.
10. 2, 4, 7, 10.
Okay. And can you find others?
No. No, 2, 4,
Sure? How about 3?
2, 4, 3, 4, 6. No,
7, 10 or 6, 10. It doesn't matter. So it's all 4. Yeah. The longest will be all 4. Length of 4. Right?
No.
Why?
Look, 1, 2. Wait. 1, 2, 3.
Yeah, it's 4. Yeah, it's 4. Yeah, you can't find many. Okay. Okay.
And then 1, 2, 3, 4, 5,
I
6,
see.
7,
Okay.
8, 9, 10.
So previously, do you remember we talked about this? Everyone is correct. We talk about this using what kind of algorithm? You know, if we use the DP, what's DP?
Dynamic programming.
Okay, if I use DPI representing the longest length of subsequence, the longest increasing subsequence that ends at index I, right? Okay, so that longest increasing subsequence ends at index I. Okay. So for example, like here,
That's index.
look, so DP value at here will be 2, right? Because longest ending at index, it will be 3, 4, will be 2, right? Yeah? And how about, look, 7 is bigger than 4, right? Look, 7 is bigger than 4, right? Yeah? So what does it mean? So what's the DP value here?
4, 7. 4.
So look, DP2 here is 2, because I found the longest increasing subsequence and the index 2 is 2, right? And I know 7 is bigger than 4. So what does it mean? So the DP here at this value will be here plus 1, right? Because look, 7 is bigger than 4. What I need to do is to put a 7 at the end of the previous longest subsequence, and it will have another one more, right? Right? So DP, right? So DP I will be maximum dpi and dpj plus 1, j plus 1, right? For j smaller than I, and what? Nums what? Nums I bigger than nums j. Okay, so that's the dp function, right? Listen to me one more time, okay? So dpi is the longest increasing subsequence, the length of the longest increasing subsequence, and the index I. And what does it equal? I just have to keep updating this for j smaller than I, if nums I bigger than nums j. Okay? Make sense?
You need the column.
No. This is pseudocode. Okay, this is pseudocode. Yeah, but you're right. Yeah, pseudocode. So why this is working? Why? Because I just said, look, if I know dp, what's the advantage of us using dp? We want to avoid repeatedly calculating the values, right? So I have dpi, meaning that the length of longest subsequence, increasing subsequence, let's say index I, right? And if I found another value, right, which is bigger than the current value, so all we can do is put a 1, append 1, because we already found one more subsequence that has the one more length, right? Has the size of one more, right? Look, everyone, look. Whatever comes here, right? Because the longest increasing subsequence ends here is 4, right? And then I found 7 is bigger than 4. So what does it mean? What does it mean?
It means we fill it.
What does it mean?
It means we plus 1.
Plus 1, yeah, plus 1. Because look, this is the longest subsequence we have found so far. And then we know 7 is bigger than 4. So all we have to do is put a 7 at the previous subsequence. And then we have a longer subsequence with size 1 more, right? That's the DP. That's the dynamic programming. Yeah, because we already save here. So we already keep updating it. And for this one, yeah, the time complexity is O(n) squared, right? Because for each I, we need to go through the j smaller than I. Okay, let's just quickly implement this. Let's just quickly implement. Define LIS array. Okay.
They all need to be capital. The I is not capital.
Okay,
but
okay.
It stands for something.
If not array, just make it return 0.
That's R.
Okay, return 0. And then n equals length of ARR. And then we need the DP value, yeah? At the beginning, it will be 1, right? Make sense? Because each individual element is a subsequent, is the longest increasing subsequent, right? Then now for I in range n, right? And then for j, every other element, every index j is smaller than I, right? In range up to I. If array I, right? If array I is bigger than array j, so then with dp I, right? Yeah, dpi will be what? Equals maximum dpi and then dpj plus 1, right? This is all we talk about, right? Yeah? Return what? That's the interesting now. What do we return?
DP.
DP what? We want to return the longest increasing subsequence. Max of what?
DP.
Yeah, good. Well done.
I did say DP.
Why is that? Because dpi is the length of longest subsequent, increasing subsequent, ending the index I. And we want to find the length of longest increasing subsequent. That could end at any index, right? So that's why we got a max dp. What's the time complexity? Well, come on. How many fours here? How many nested fours here?
O(n)².
What's the space complexity?
O(n).
Well done. Because this
We
is
said that at
that.
the same time. Yeah.
Well done. Okay.
The end. Bye.
Okay. So this is just the review. We have learned this before.
It's
Okay.
gonna take forever.
Look. And look. 3, 2, 10, 7, 8, 10.
You said we're gonna do it for 10 minutes.
Okay,
It's
okay.
already nearly 10.
Okay. Come on. Listen to me.
Now it's 10 minutes.
What's the longest increasing subsequence here? What's the longest increasing subsequence? The length of longest increasing subsequence?
3, 7, 8, 10.
3, 7, 8, 10, 4. Okay. So we have another algorithm, right? So we can have a least longest increasing subsequence, right? At least, and then we can build it. Yeah, we can build it along the way. So look, how can I build it? Look, how can I build it? So at the beginning we have nothing, right? So how we do it? 3. So let's see this longest increasing subsequence. It should be sorted, right? It should be sorted. Yeah, it's sorted, right? Because it's sorted, right? The longest increasing subsequence. Increasing subsequence, what does it mean? It's sorted. So 3. If I'm going to put it in the longest subsequence, where is it going to be? It's empty now, so I can just put it there, right? So longest subsequence will be 3. Okay? 2. We're going to put it here in the sorted list. It should be before 3, yeah? Remember, yesterday we talked about what?
Bisect left and bisect right.
Bisect left. If we bisect here, so where should put it? We should replace here, yeah? Yeah, this is the place to put a 2 in. So I replace it into 2. Why is that? Why is that? Because if I don't know what's happening afterwards, but all I know is that if I change the 3 to 2, it will only make the result better. Am I right? Because 3 is 2. I'm changing the sequence of a big number to a smaller number, so it doesn't make the result worse, right?
Yeah, but what if? But I don't get it, because because 3, can you put like 3?
3? There's only one 3 here.
Yeah, but what if there's like 2 of the same one? Can you put them together?
Good question, very good question.
Like they're 2 10s.
No, because long is increasing. 3 is not increasing. Right? It's not increasing.
So just put 3.
We only have one 3. Because if there are 2 3, you can put this is not increasing. This is not increasing, right? Right, so look, so what did I say? So previously longest increasing subsequence is 3. Now I have 2, right? I mean 2. So I can change this to 2. 3 to 2. And this doesn't make the result worse, right? Because I'm changing a sequence. I don't know what's after, but all I know is that I change a big number to a smaller number. Yeah, you will not make the result worse. You will only make the result better. Yeah, because there's some, for example, there's another number 2.5 here. Previously 3 is decreasing, but now I change it to 2. It might increasing, right? I might pick this in the future. Right, so let's create it. So I change this. I use the bisect left, yeah, bisect left, to find out the place. Yeah, 3, and I change it to 2. Okay, 10. Where it's going to put in the sorted here?
At the end.
At the end, so I put it here. 7. Where are we going to put?
Bisect left 10.
10. Yeah, so I replace this again. I replace this to 7. Yeah, because I changed 10 to 7. What does it mean? Yeah, the result could only get better, right? A, where do we put?
After 7.
After 7, then I put an A. Where is it going to put?
10.
Okay, and the length is?
4.
Okay, going through one time, ON, right? But bisect, what's the time complexity of bisect?
Of logn.
Logn. So altogether, ON,
Logn.
which is better? This better or ON square? Which is better?
Ln logn.
This is better. Yeah, we find the better error. Yeah, makes sense? You understand? Yeah, perfect. Let's do this. Define longest increasing subsequent array. And we need to have an empty list. We go to put this.
LIS supposed to be capital.
No. For the variables, it's okay. It's okay. Then we go through this for I in ARR. Okay. Then we go this x equals bisect. Remember bisect. What's the bisect left? Yeah, bisect left. The first parameter will be the ARR. And the second parameter will be no. We go to bisect in the list. Yeah, in the list, not AR. And then I. Yeah. If Well, x equal length. The position is at the end, right? It means that we can put it at the end, right? We can put it at the end, right? We can put it. How can we put the element I in the end of list? List dot. What's the method? We put this I. We want to put this I in a list. In append, yeah. Append I, right? Or you can do this lis plus equal I. This is also okay. This is the same thing, okay? This is the same thing. Otherwise, we just need to change what? lis what? What equals what? Okay, so what? Look. What did I just say? 7, 10. And if I have a value 8, I want to replace this with 8. Anybody?
We change to 10.
So x equals what? So the x is bicep, yeah? We got this position, insert position, and equals to the number, yeah? Which is I. Right? And we just need to return what? Return what? Return what? Come on, this is easy.
Return this.
Return what's the length of the longest increasing subsequent at the end?
4.
Length of what?
List.
List. Yeah, list, okay. Make sense?
Yes.
Make sense? Yeah, let's just double check. Yeah, I think it's alright, yeah, it's alright. Okay, so this one we call it greedy, yeah, because we greedy. Every time we find a smaller number, yeah, we find a small number, we replace the one in the list with that position, because we always keep this maintaining a sorted AIS, right? So we replace it, we greedily replace it, and then that will give us the result. Yeah? Am I right?
Yeah.
What's the time complexity for this one again?
NLogN.
What's the space complexity for this one?
N.
Oh, and this. In the worst case is what? Everything is increasing. 1, 2, 3, 4, 5. So this, the list will contain this 1, 2, 3, 4, 5. Okay? This longest increasing subsequence. Make sense? So the first one, dynamic programming, yeah? Dynamic programming, you understand, yeah? And this one is greedy. No, dynamic programming, ON square. Remember?
And space complexity.
Oh,
Yeah.
Okay, that's it for today. Good job. Bye-bye. Bye-bye.